Welcome to this FP2 video on algebraic methods, and this is part of the inequalities chapter. So if I have an inequality like minus 2x is less than 8 and I want to divide this by -2, then the 8 would become -4, but the sign would change, okay, because I'm dividing or multiplying by a negative number. And another way of looking at that is if I've got the -2 and the 8, if I take the -2 to the other side, I'm effectively adding plus 2x to both sides. I get 0, and then this is 2x plus 8. And then if I take away 8 from both sides, I get -8 is 2x, and x is -4. So x is greater than -4, which is what we've got here. So dividing, and the same with multiplying by a negative number, changes the sign. Now, what happens if I have to divide by a variable? Like, so if I'm dividing by x, for example. Now, if I'm dividing by x, I don't know what's going to happen to the sign. Okay, so if I've got a question like this, and in this case, I'm going to multiply. So if I multiply by x, I've got 1 is greater than x squared. However, that x, I don't know whether that was positive or negative, because I could have ended up with this, or I could have ended up with this. And that becomes a little bit of a problem. Okay, so let me just sketch this graph to show you. So here I've sketched for this graph, okay, and at this point here where they meet, this is going to be when x is 1, and this one when x is -1. So where this graph, the 1 over x, the curved graph, is greater than the x graph, is going to be in two different places. So it's going to be between 0 and 1, isn't it? It's going to be between here and here. So 0 and 1, and it's going to be then less than -1, because as we go past -1, the x is greater than the 1 over x. So what I've got left with is x is less than -1, or x is between 0 and 1. Okay, and obviously at 1 they're both exactly the same size. Now when I look at, now let's just rub this one out here for now, but when I look at this graph, let's draw this one, and we end up with this. So there's my x squared, there's my 1. 1 is greater than x squared between -1 and 1. So now we've got that x is between -1 and 1, which is clearly not the same as this solution, is it? Okay, so multiplying by x doesn't give me the same set of answers, and it's purely because x could be negative and it could be positive. So it does mess up my solutions. So this method here is no good. So what can we do? Because we don't necessarily want to have to sketch things out, especially when we get more complicated ones. Okay, we will need to sketch things, but hopefully simpler things. So what we can do is we can multiply by a squared term, because if it's squared, it's always positive. So if I take that 1 over x is greater than x. And if I multiply both sides now by x squared, so I'm timesing by x squared, then what I end up with is that will cancel with that, so I'm left with x is greater than x cubed. And what I can do then is I can take these to one side. So I can take it to that side, or I could take it the other way. And, you know, before I will look at the sketch, what we can do then, we can have x squared minus 1. So this is x plus 1, x minus 1. So our critical values are x equals 1, x equals minus 1, and x equals 1. Okay, so those are going to be our critical values. But let's look at the graph. So the graph will look like this. This is the x cubed graph, and then the x graph here. Okay, and we want first to know these critical points. Well, we've already worked these out, so it's 1, 0, and -1. Okay, so that's where the graphs meet. Now I can look at what's happening. So I want when x is greater than the x cubed graph. So when the black line is above the blue line. So it's above the blue line between x is 1 and x is 0. So one solution is x is less than 1 and greater than 0. And then it's above the line when x is less than -1. Because as this goes down, this is going to stay above it. So it's this, or x is less than -1. And that is exactly the same solution as we had here. So multiplying by the x squared didn't change our solutions, but multiplying by x did. Okay, and it's all down to the fact that that variable could take a negative value, and multiplying or dividing by a negative value changes the inequality. So when you get these inequalities, it is quite tempting to treat them like an equals and just multiply by the x in this case, you know, and solve. But, you know, you can see you need to multiply by that x squared. So what's on the bottom squared, what you want to multiply by, but square it. Okay, now let's have a look at an example. So in this example, I've got x squared plus 3x over x minus 1 is less than x plus 4. So like I mentioned previously, you know, there will be some sketching involved, but we don't want to have to sketch these graphs because these are going to be difficult. So we want to sort this out first algebraically and then do a simple sketch so that then we can get the solutions. So in this case, I've got x squared plus 3x over x minus 1, and that is less than x plus 4. So I am going to multiply both sides by x minus 1 squared. Okay, obviously what I've written in red you wouldn't need to do in the exam or anything, you can jump to the next stage. So we've got x squared plus 3x times by x minus 1, and we've got x plus 4 times by x minus 1 squared. Obviously this x minus 1 will cancel one of these. Okay, now I need to take everything over to one side. It doesn't matter which side I do it, so I'll take it over to the left. So I've got x minus 1, x squared plus 3x minus x minus 1, or let's put the x plus 4, x minus 1 squared, and that's less than 0. Now I can factorise out 1x minus 1, and I'm left with x squared plus 3x minus x plus 4x minus 1. Now what I need to do is expand this bracket here. Okay, so I'll just do it over the side here. So x plus 4, x minus 1 is going to give me x squared plus 4x minus 1x, so plus 3x minus 4. And then I'm going to be taking away, so each of the signs of these will change. So I've got x minus 1 on the outside, and then I've got the x squared plus 3x still on the inside. Then it's minus x squared minus 3x plus 4. So x squareds cancel out on the 3x's cancel. So we're just left with 4 times x minus 1 is less than 0. Okay, so that's what I'm down to. Now I can see that x minus 1, so 1 is going to be a critical value. So you might have more than one critical value. You could have 1, 2, 3. In general, you won't really have more than 3. So critical value x equals 1. We're going to need that. Now we need to sketch. So sketch y equals 4x minus 1. So 4x minus 4 effectively. So I'll do it over here. So quick sketch is going to look like this. I've got 0, and then this value here is going to be 1. So when y is equal to 0, then x would obviously be 1. Okay, which will make it equal to 0. This would be minus 4, but we're not worrying about that value at the moment, because we want now when the graph is less than 0. So we want below the 0. So our solutions are x is less than 1. And you can show this in various ways. So you can set it up like, so it's between minus infinity and 1. Okay, and it can't be 1, so we put a curved bracket. If it equal to 1, we put a squared bracket there. Sometimes it asks for set notation, which wouldn't really be appropriate in this question because we've only got, one range of values. Okay, so there we have the first example. We're going to do a second example in a moment, but in the meantime, if you are finding the video useful so far, hit that like button, hit that subscribe if you are yet to subscribe, and hit that join button if you're willing and able to help me out financially. Otherwise, let's look at the second example. So in this example, I've got two fractional algebraic fractions in terms of my inequalities. So this time I need to multiply by x minus 2 squared and x plus 4 squared. So we're going to multiply by them both. So we've got x plus 1 over x minus 2, and that's 3 over x plus 4. And we're going to multiply both sides by x minus 2 squared, x plus 4 squared. Okay, so that is both sides. X minus 2 squared, x plus 4 squared. So like that squared will cancel with that, and this squared will cancel with that. Okay, so what that's going to leave me with on the left side is x minus 2 x plus 4 squared, x plus 1. And on the right is 3x minus 2 squared, x plus 4. And now I can take everything to one side. I'll take everything to the left. So we've got x minus 2, x plus 1, and x plus 4 squared. I'm just putting the squared at the end there. And 3x plus 4, x minus 2 squared. And that's greater than or equal to 0. Now factorize it out. I can factorize out an x minus 2 and an x plus 4. And then that leaves me with x plus 1, x plus 4, minus, and then I've taken out an x plus 4 and an x minus 2, so that leaves me with 3 and an x minus 2. And that is what's left now inside the big brackets. So now I've just got to simplify and sort this out, which initially leaves me this, and then collecting like terms. Now, normally I would factorize out or factorize this bracket, but looking at it, the b squared minus 4ac is going to be negative, okay, which means that this is going to have no real solutions. So in this case, I'm only going to have two critical values, and my critical values are going to be at x equals 2 and x equals negative 4. So sketching this graph here, so y equals that, it's kind of just going to look like an x squared graph where my values are minus 4 and 2. Okay, obviously that's because this one had no solutions. Okay, otherwise it might have crossed a couple of times. So, you know, each question's a little bit different. But now I can go ahead and look at the solutions. So the solutions for here are when this graph is above the 0, so above the x-axis here. So it's going to be to the left of minus 4. So x is less than minus 4, or x is greater than 2. Okay, so that's when it's going to be above 0. It includes 0, so just double check, but it should include these two values. Okay, but you might need to stick them in just to check. Now, in our case, x cannot equal 2 and x cannot equal minus 4. So these are not going to have equals by them. Okay, but in some cases there will be equals there. So you do have to just be careful of whether you put an equals in or not. You know, refer to the question. If this was between two values, then one might have an equals, and then this one wouldn't because it cannot equal that value. Now, in terms of set notation, then we want to write it out like this in its largest form. So x less than minus 4. And then u for or, and x greater than 2. Okay, so that's just putting it in set notation, as that's what the question asked for. And an alternative way of writing this is from minus infinity to minus 4, or from 2 to positive infinity. And this notation uses curved brackets for like less than or greater thans, and squared brackets, so like a squared bracket like this for when it's equals to. So like this means x is less than -4, and if I put a squared bracket on it, it would mean it'd be less than or equal to -4. Okay, so this is just another notation way of writing your answer in like that set notation. Okay, different examples do favor different kind of notation, but they're all acceptable. Okay, so there is the second example. I think now we'll do a couple of questions for you to have a go at, by which point then you can have a go at, questions from your textbook, or, questions from online sources, ChatGPT and so on. So 3 questions for you to have a go at here. These are generally like the first part of a larger question, and they are past paper questions. Okay, so have a go at these 3. Pause the video now. Welcome back. Let's have a look at the solutions. So for this one, we need to multiply by x plus 5 squared and x plus 4 squared. So I will be left with x plus 5, x plus 4 squared, 2x plus 1. Just jump into this step. X plus 2 times by x plus 4 times by x plus 5 squared. I'm going to take everything to the left. You can take it to the right. You'll get the same solutions in the end. So x plus 5, 2x plus 1, x plus 4 squared, minus x plus 2, x plus 4, x plus 5 squared, and then that is less than 0. So I can take the x plus 5 and the x plus 4 out, and I'm left with 2x plus 1 and x plus 4 minus x plus 2 and x plus 5. So I just need to expand these now and simplify. Now I need to work out the critical values. So my critical values are x plus, not x plus 5, x equals -5, x equals -4, and I need to sort this out. Now this doesn't factorize, so this I will need to use the quadratic formula. So this, use quadratic formula. Okay, and what I get from that is then that x is -1 plus or minus √7. Okay, so I wouldn't jump straight to this answer. I got this from my calculator, but you need to use the quadratic formula. Okay, so show your workings out, or show some of your workings out there before you jump to this line. Okay, now I can go ahead and sketch this graph. So it's a quartic. It's going to pass at these 4 points. Okay, so this one is -3.65 the 2 decimal places or 3 significant figures, and also 1.65 when I do the positive minus 1 plus root 7. So it's a positive quartic, so it's going to be coming down this way and down this way. So it goes down, up, down, somewhere down there, and then back up. You can work out this bottom value here. 5 times 4 times minus 6 is minus 120. So it crosses down there. So now I've got a rough sketch. I know my sketch is pretty bad here, but it's there just to show you. So when the graph is less than 0, that's what we want. So when it's underneath 0. So it's between minus 5 and minus 4. So x is less than minus 4 greater than minus 5, or now it's minus 1 minus root 7, is that 3.65, so it's greater than that and less than minus 1 plus root 7. And we can write this as minus 5 comma minus 4 u minus 1 minus root 7 comma minus 1 plus root 7. We can write it with these brackets, or I can put the curly brackets and the thing inside it, like these, you know, these inside it. Doesn't really matter. Okay, you guys know what set notation is, or you should at this point. Okay, since this is, you know, further maths course in upper 6, FP2. Anyway, that is question 1 complete. Let's look at question 2. So we've got our values x and 1. We're going to be multiplying by 2x plus 1 squared, x minus 3 squared. So on the left, I'm going to have 2x plus 1, x minus 3 squared times by x, and this 1 is going to be times by x minus 3, 2x plus 1 squared. And then again, I'm just going to take everything to the left, but it's up to you which way round you do it. You can take things to the right if you prefer. And there we have it. So we want to factorize out x minus 3 and 2x plus 1. That leaves me with x minus 3 minus 2x plus 1. I'm just using squared brackets there just so you can differentiate between, you know, what's going on. Now all I need to do now is expand and simplify inside the squared brackets. And there we have it. Okay, this now doesn't factorize, so again now I'm going to have to use the formula. B squared minus 4ac is positive, so it will have solutions. Okay, so this point, remember, quadratic formula. Don't just use your calculator. Use your calculator to check, but don't just use your calculator. You need to show the maths involved. Okay, obviously I'm not going to bother writing it down here. You can all use the quadratic formula. So critical values are x equals 3, x equals minus a half, and x equals 5 plus or minus root 29 over 2. So it's a quartic graph and it crosses in 3 places. So first of all, 5 minus root 29 divided by 2 is minus 0.19 or minus 0.2. So we got minus a half. We've got minus 0.2. Now, 5 plus root 29 over 2 is 5.2, 5.19. So our next set of values here we've got is 3 and then 5.2. Okay, now this graph here, if I look at the x's, x times 2x times x squared is going to be positive. Okay, so it's going to be a positive graph. So that means it's going to start coming down there and it'll be ending going up from the 5.2. So we're going to go down below and up to the 0.2. We'll cross this line and then we go down to the 3 and up to that 5.2. This point here where it crosses the y-axis, we can see minus 3 times 1 is minus 3 times by minus 1 is plus 3. So this is going to be at just that 3 there. Okay, but I don't need to worry about that. Okay, the sketch is just so that I can set out my set of values. So we want when the graph is less than 0. So when the graph is below the x-axis. So our values are that x is between 5 minus root 29 over 2 and minus a half, or between 3 and 5 plus root 29 over 2. Okay, obviously this asks for it in set notation. So using the standard set notation from Pearson, I get, don't forget the minus there, this. Okay, and that is it in set notation for you. Okay, so there's question 2 done. Okay, hopefully you didn't have too many problems with that one. Now let's look at number 3. Now, question 3 was a little bit different. Give you a triple inequality. And what we have to do is consider them separately and then find the common solutions that work for both. So first we're going to consider 4 over x as less than x. So that's the one I'm going to consider first of all, and I want to multiply by x squared. So that's going to give me 4x is less than x cubed. Now, again, I can take it either way, and I'll show you it doesn't really matter. So this time I'll take it this way. So that means x is x squared minus 4. X squared minus 4, difference of 2 squares, isn't it? So x plus, not 4, x plus 2 and x minus 2. Now these are my critical values. So critical values are x equals 0, x equals -2, and x equals +2. Now this graph is a cubic, so let's sketch that, and it crosses at -2, 0 and +2, and if I look at the x's, they give me a positive cubic, so it's going to be from the bottom to the 0, through the 2 and up. Now we want when the graph is greater than 0, so we want the graph above the x-axis. So it's above the x-axis between 0 and -2, and it's above the x-axis when it's greater than 2. So that's what I've got so far. Now let's look at the other one. So now we're considering the x is less than 1 over 2x plus 1. And now I'm going to multiply both sides by 2x plus 1 squared. So that's x, 2x plus 1 squared is less than 2x plus 1. Okay, and this time I'll take everything to the left. 2x plus 1 squared minus 2x plus 1 is less than 0. Just to show you it doesn't matter which side I take them to. So for this now I can factorize out 2x plus 1, and then that leaves me with x, 2x plus 1 minus 1. Now I'll expand and simplify inside the brackets, and then this time it's not the formula, it'll factorize, so 2x and x, and it's 2x minus 1x plus 1, I think. 2x squared, 2x minus x gives me plus x, and minus 1 times 1 gives me the minus 1. So this is my fully factorized bits, which means that my critical values are x equals -1/2, x equals +1/2, and x equals -1. And again, I've got a cubic, haven't I? 2x times 2x times x gives me a positive cubic, a 4x cubed graph. So let's sketch that. So quick sketch, and we're going to cross at -1/2, -1, and 1/2, and it's positive, so it's going to come from the bottom like that, like that, and this is going to be crossing at 1 times -1 is -1 times 1 is -1. So this one crosses at -1, the y-axis. So just sometimes it's worth just putting that bit in just to check that you've sketched your graph right and it still makes sense. Now I want when my graph is less than 0. So it's less than 0 when it's below the x-axis. So we've got x is less than -1, or x is between -1/2 and +1/2. So that leaves these solutions. This one from the first one that I did, and then this one from the second one that I did. And I've got to find the set of solutions now that work for both. Or in set form, I'm currently looking at this set of solutions must intersect with this set of solutions. So if I'm looking here first of all, I can see this is between -2 and 0, and this is less than -1. So what I can infer from that is that it's got to be less than -1, but then greater than -2. So that is one set of inequalities that take out this and this one. And then this is x is greater than 2. And this now is between -1/2 and 1/2. So that doesn't work. This doesn't overlap with anything here. Okay, so this doesn't overlap with this or this, does it? But if I do look at this one actually does overlap with this one. Now we use this one with this one, but we can also use part of this one with this one. Okay, so if I look at it, this is between -2 and 0, and this is between -1/2 and +1/2. So I can say that this will become between -1/2 and 0. Okay, so that therefore is my set of solutions. And what you can do if it does get confusing is you could always draw like a number line with your, some values on it. Let's put them in halves, for example. So like a half or -1/2, 1, -3/2, 2, -2, and so on, going that way. And we've got between -2 and 0. We've got between -1 and infinity. So it's a 1/2, 1, 1.5, 2, and so on. We've got from 2 and more, so that isn't going to overlap with anything. And then we've got the -1/2 to the +1/2. Okay, and what you can see is the overlaps. So there is an overlap here, which is what gives me this inequality. And then there is an overlap here, which is what gives me this inequality. And these two inequalities are separated from each other, which is why we have an or. So if in doubt, you can sketch out a little number line and look for where your inequalities overlap. And it's only where they overlap which will become the solutions to the whole thing. Okay, so hopefully you did find this useful. If you did, hit a like, subscribe if you're yet to, and please consider helping me out and joining, if even just for a month. Every little helps, as they say. So see you in the next video.